So welcome you all for the DIP class, or Digital Image Processing as we call it. Today we will have a small background to the digital image processing. So what does the word digital image processing suggest? So if you look at the word carefully, it is composed of, or look at the phrase carefully, it is composed of three words: digital, which corresponds to numbers; image we are all familiar with; and processing. Processing means bringing change. So basically, digital image processing involves firstly the digitizing images, or having the images in digital form, that is in the form of numbers. So we take the images in the form of numbers first, and then we process those numbers. So in that process, the entire image gets processed. So that's the idea. Very strictly, the digital image processing does not deal with how the digital image has been created. How has it been created? We are not bothered much about it. We are only bothered mainly about once the digital image is handed over to us, how do we process it? So, although we are going to look at some of the imaging techniques in a very brief manner, but not in a very detailed manner. So I hope that is clear. Why do we need the processing at all? Why do we need the image processing at all? So remember, the imaging technologies evolved around 1850. If you look at the history of imaging, modern day imaging, painting also is an imaging technique, and painting has been there for thousands of years. Cavemen, we have paintings from the cavemen as well still available. So painting has been there from, say, maybe 10,000s of years or even older. But modern day imaging techniques evolved around 1850 onward, when initially it was chemical in nature. You must have seen negative, photo negatives, etc. And then somewhere at the end of 20th century, it got electronic in nature. So present day imaging is electronic in nature. However, the digitization of images did not start immediately around 1850. It took some time. It took around 60 to 70 years of time to start for the digitization of images. So the question was, what was the need of digitization? Why do we need digital images? The answer to this question has two folds. One, you try to digitize the image so that it becomes better. Improvement of pictorial information for human perception. So certain images you will find that they are not great. Sometimes exposure is poor. Sometimes it's too bright. Sometimes you will find that colors are not great. Sometimes shapes are not proper. So if you digitize it, then it becomes easy to process, make it better. The other reason why you needed processing is for machine perception. So present day imaging is a very widely used technique all throughout in the industry, in fault finding, corrections, etc. Finding it is a very important technique for finding fractures in human body, strains in medical field. So lots of applications. So the second is the machine perception, that is very important as far as imaging is concerned. One of the third requirement of digitization, remember up till now I was talking about processing. The digitization was required to transport the image from one place to other place. So if you look at the early world, say world in say 20th century, 100 years before, like 1920, a world of 1920, then an image clicked in Europe would perhaps take around a month to reach to US, or an image clicked in India used to take at least a month to reach to London. Why there was so much time? The answer was that first you click the image, you develop the negative. At those times were glass plates. You develop the glass plates, you uh, print the image, then you ship from here to say some. If you want to publish the image in some newspaper, then you are needed to take it via ship to the London, and that used to take a lot of time. While other communication channels were very fast, typically the telegraph was available and it was a fairly fast means of communication. So people always thought that somehow if you can transfer the image by telegraph, it will be great. But for that, you cannot transfer a physical image via a telegraph. You have to convert them into digital form, in form of numbers. Once the image is available in the form of numbers, then the same numbers can be transferred anywhere across the world, and the receiving person can recreate the image from the numbers. So we will see those examples. So we need processing to improve the pictorial information for human perception. How an image or a video is nothing but a series of images. So how can an image or video be made more aesthetically pleasing? So for example, if I have an image over here, now it is a decent image, but can I make it more aesthetically pleasing? Answer is if I make some changes here and there, maybe yes. I can change the brightness, I can change some other parameters, and you can see that the right hand side image is more aesthetically pleasing than the left one. In fact, in the present day mobile phone photography age, most of us are familiar with these processing changes. That you can increase the brightness, change contrast, etc. etc. And that is what we are going to learn in this course. The other advantage is for the machine perception. So one of the things that happens in India or in Mumbai also, that reading of number plates, car number plates, happens automatically by using camera capture. So suppose that there are many signals and suppose you jump the signal, the camera captures your car number plate, car image. From the image of the car, it captures the number plate automatically, and once the number plate is captured, it is segregated, all the letters are segregated from it, compared with the standard reference, and these numbers are recreated. In fact, in the present day technology, we are doing much more than this. The software checks on whose name the car has been registered, it sends a challan to that person's account, and sometimes it also withdraws the money from that person's account. So all of these things are happening, and image processing is playing a very important role. Most of you have now you have seen our mobile phones. They unlock the phone using face detection. That is another example of machine perception, where you perceive the image of the face, compare with the reference, and then you unlock the phone if it's matching. Same thing happens when you have a fingerprint detection. So if you moment you touch, an image of the fingerprint is taken and it is compared with the reference, and then phone is unlocked if it's matching. So all these are examples. I mean, they are all around us. Image processing is all around us. So it's a very important subject in day-to-day life, and of course in astronomy, astrophysics, where in which you are going to specialize for your MSc, and where the imaging is only tool which is available. I mean, mostly the only tool which is available to learn about the universe which is beyond solar system. Very few of our spacecrafts can go far beyond solar system and still send us live signals. Very few. So imaging is the only technique available. In fact, this year's Nobel Prize has gone to the people who created the image of the black hole, again using digital image processing, DIP. So we are actually starting a subject which is very, very interesting, very wide in applications. So, what were the initial efforts? It's very interesting to know some of the historical aspects, and that is what we will discuss in today's class. This is one of the earliest, maybe I think the first image which was digitally transmitted across Atlantic. When you say across Atlantic, mostly between North Europe and North America. And you will find that these are some dots appearing over here, some sporting event. So 1921. So how this image was transferred? So roughly I can explain you the process. I will not give you all the details, but idea was straightforward. You first digitize the image. So image was digitized at the source. How? What is digitization? Digit means numbers. So image is converted into numbers. That means every point on the image correspond to a number. You can have your standard. Maybe when it is brighter, that number can be large. When it is darker, the number can be small. And you can convert the image into a number. Once it is converted, it was transmitted by a telegraph cable using Morse code most likely. So Morse codes were developed to transfer signals across telegraph cables. So uh, you can click on your transmitting machines those numbers, and receiving printer will receive those numbers and print accordingly. So special typefaces were connected so that the print image can be printed. It was not one and two, but something special, different. And the image was transmitted. You can see that image was not very clear. It's very blurred compared to any standard, but still it was a great success. So it is a poor visual quality, poor print, that mostly due to printing, and also it was poor because of distribution of brightness levels. So you can see that this is almost white and this part is almost dark, while in practice there will be some smooth gradations. Now the other image which was there was printed by using different technique using punched tapes that actually crossed Atlantic twice. So once from Europe to US and then come back. So at least it jumped twice the ocean and still retained its visual quality. You can see that it was slightly better than the previous one in its tonal quality and resolution also. The points here are closer. The image quality is better here. So this was another effort next year. These were very early efforts. And then this was a 1929. It was a 15 level. When you say 15 level means between completely bright and completely dark, there were 15 different shades of gray. So 15 levels were there, while the earlier only 5 levels were there. So if you increase the number of levels of gray, you will increase the gradations. So you can see that there is a white and there is some light gray, there is some dark gray here, and there is almost very dark gray here. So a lot of shades are available, which was not available in the in this case or in this case. In this case, it was largely bright or dark. So as you increase the number of levels, your tonal quality improves. And this was printed not by a normal printer, but it was transported onto a film plate which was developed. So it was developed by much better method. It was 1929. Although these efforts were very much limited in the very beginning because of one major reason, that once you convert an image into a digital image, processing large numbers was a challenge. It could not be taken, it could not be done very smoothly or very effectively until we got the large scale digital computers. Large scale digital computers started arriving. The first large scale digital computer was made was 1931. I hope you all are familiar, ENIAC. And in 1940s and 50s, these developments started. And then came the great space race of 1950s and 60s. As you all are familiar, in 1950s and 60s, the US and USSR were in Cold War with each other, and one of the targets was to actually uh, land a manned mission on the moon. So there was a space program that was going on, and that actually gave a big boost to image processing. So a lot of infrastructure and people were devoted to image processing in those days. Computers, the large scale computers, the mini computers were still not available, but large scale computers were available. And a lot of work was done in those days. Pre-Apollo and Apollo moon missions, typical requirement was to correct various type of image distortion inherent on onboard television cameras. So there were television cameras fitted on the spaceships, but they used to produce images with lot of distortions. So you needed to correct those distortions, and therefore you needed image processing and image processing algorithms. So various missions. I have one example to show you. This is July 1964 image of a spacecraft, Ranger 7. So it was a spacecraft which is like our Chandrayaan mission, which actually crash landed on the moon surface. Even this had crash landed on the moon surface. But this is the image that it has sent before crashing on. You can see that it was very clear. Of course, it has been corrected later on, but it has a very clear image. And from that day, lot of things happened. The mini computers and microcomputers got developed in 1970s, 1980s, 1990s. I particularly witnessing this development from late 1990 onward. And when we started learning Photoshop and other techniques, and now image processing is everywhere. It is inside your phone. uh, Video cameras are everywhere. All, in fact, right now, all we are doing is by using digital image processing, including this lecture reaching to you, is using it. So we can stop today's work here. Thank you.